So question 14, a particle is projected from a point O on horizontal ground at an angle alpha to the horizontal. The initial speed is 35 meters per second, and the particle strikes a target whose position vector relative to O is 50I plus 50j meters. Find the two values of alpha correct to the nearest degree. What's another name for a position vector? Displacement vector. So position vector and displacement vector are exactly the same thing. So you should always represent this information on a diagram. So if we draw our I and j axis, so the I is the horizontal, the j is the vertical. So the particle is always projected from the origin. Okay, so the starting position is always the origin. The tangent vector from the origin is your initial velocity vector u. Now we're just told that the speed is 35 and that it makes some angle alpha. So we're looking to find the two possible values of for alpha for the particle to reach this point up here. Now at this point, the vertical height sy is 50. So we got that from 50j. So sy is 50, and sx, the horizontal displacement, this is 50 also. So sx is 50. Okay, so that's got from your position vector. So a position vector and a displacement vector are the very same thing. So r is equals sxi, so this is sx, plus syj, this is sy. So sy was 50 and sx is 50 also. So the initial velocity vector u, it's always the speed times the cos of alpha times I plus the speed times the sine of alpha times j. Okay, so this is the equation for the initial velocity vector. That's not given in the tables, that's something you need to know off by heart. So here then it means u is going to be 35 cos alpha I plus 35 sine alpha j. Okay, so this is the initial velocity vector. So ux is the coefficient of the I and uy is the coefficient of the j. So this means that 35 cos alpha is ux and 35 sine alpha is uy. You cannot answer anything without knowing what ux and uy are, or having expressions for them, which we have here. Okay, so in order to find the two values for alpha, we're going to use the two conditions that sx equals 50, and this occurs when sy equals 50 also. So sx equals 50 when sy equals 50. Now, which of them two equations is the easier to start with, sx or sy? What is the equation for sx? uxt. So sx just equals ux times t. So this means 50 equals ux is 35 cos alpha. So the ux is 35 cos alpha times the time t. Now we're going to get t on its own. So t on its own is going to be 50 over 35 cos alpha. But what number divides into the 50 and the 35? 5. And what's 50 divided by 5? 10. 35 divided by 5? 7. So that does break down as t equals 10 over 7 cos alpha. So instead of 50 over 35 cos alpha, we can write that as 10 over 7 cos alpha. So we can now substitute that value for t into the equation for sy. We're told that sy does equal 50. Now the equation for sy though, sy equals uyt minus a half g times t squared. So this means, what number are we putting in for sy? Sy is 50. This equals, what are we putting in for uy? (35 sine alpha). And what are you putting in for the time t? 10 over 7 cos alpha. And then this is minus a half g times, and again the time, we're going to replace t with 10 over 7 cos alpha. Okay, next of all, 7 does divide into 35. You what? And what's 5 by 10? 50. Now, what about sine alpha over cos alpha? Tan alpha. So 50 is going to equal 50 tan alpha minus half a g is 4.9 times 10 squared is 100 over 49 cos alpha. Cos squared alpha. Okay, so squaring a fraction, square the top, you get 100. Square the bottom, you get 49 cos squared alpha. Now here, the 4.9 divides into 49 to give 10 in the bottom. Now 10 in the bottom then divides with the 100 in the top. So what would these all simplify to, these constants? We're going to get 10. Okay, so 4.9, but 4.9 by 100 is 490, and 490 divided by 49 is 10. So this means 50 is going to equal 50 tan alpha minus 10 all over cos squared alpha. Now we could actually now divide everything by 10. So the zeros will cancel. That 0 goes, that 0 goes, and that goes. So we're just left with 5 equals 5 tan alpha minus 1 over cos squared alpha. Now, with every single one of these questions, we always use this same trigonometric identity. What does 1 over cos squared alpha equal to? 1 plus tan squared alpha. Okay, that's called a trigonometric identity. That is given in the maths and formula tables. Okay, and we always use that every time we do one of these questions. So we're going to replace the 1 over cos squared alpha with 1 plus tan squared alpha. So we're going to replace this with 1 plus tan squared alpha. So 5 is going to equal 5 tan alpha minus, in brackets, 1 plus tan squared alpha. Now, minus by 1 gives minus 1. Minus by tan squared alpha is minus tan squared alpha. So this means 5 equals 5 tan alpha minus 1 minus tan squared alpha. Now, if we have a minus tan squared alpha on the right, what happens if you bring that over to the left? Positive tan squared alpha. What happens if you bring 5 tan alpha over? Minus 5 tan alpha. If you bring the minus 1 over? Plus 1. So this means tan squared alpha minus 5 tan alpha plus 6 equals 0. Now, what are the factors for tan squared alpha? Tan alpha by tan alpha. What's the possible factors of 6? We could use 1 and 6 or 2 and 3. But if we want to get a minus 5, we need a minus 2 and a minus 3. Is that okay? Because minus 2 by minus 3 gives a plus 6. Okay. So we have to have tan alpha minus 2, tan alpha minus 3 equals 0. So this means tan alpha equals 2 or tan alpha equals 3. So alpha is going to be inverse tan of 2, or alpha is going to be inverse tan of 3. Now, if we store both of these answers in the calculator, because we want to use these exact answers for the next part, calculate the times. Okay, so just to show you again how to do that, and storing it on your calculator. Okay, so if you press Shift inverse tan of 2, close the bracket, and equals. So that works out as 63.4349. Now, what is that answer anyway to the nearest whole number? 63. Okay, but we're going to store this exact answer in your calculator. If you press Shift, store memory A, that stores the exact answer in memory A. Okay, and then if we want to find the time of flight in each case, correct to 2 decimal places. So we had the time t was 10 all over 7 cos alpha. So this means that one of the times is going to be 10 over 7 cos recall A. Okay, so that's going to be 10 all over 7 times the cos of recall A. Okay, so A was inverse tan of 2. So if you type in 10 over 7 cos recall A, I'll just show you that process. So using our calculator, press the fraction button. We've got 10 all over 7 times cos of recall A. And close your bracket. And that works out as 3.19 seconds. Okay, and then the other angle of alpha was inverse tan of 3. So t is going to be 10 over 7 cos. And if you press recall B, that works out as 4.52 seconds. Okay, question 15 then. A particle is projected from a point O on horizontal ground at an angle alpha to the horizontal. The initial speed is 35 root 5 meters per second. The particle strikes a target whose position vector relative to O is 350I plus 210J meters. Find the two values of alpha correct to the nearest degree. So again, if we want to represent this on a diagram, the point of projection is always from the origin, and the tangent vector from the origin represents your initial velocity vector u, and this is 35 root 5. Sx is 350 and Sy is 210. So that diagram shows the position vector. Okay, so at this point here, the vector from the origin to this point is your position vector. And again, what's another term for a position vector? Displacement vector. So again, your initial velocity vector u u is u cos alpha I plus u sine alpha j. Now here, what's the speed u? 35 root 5. So u is going to be 35 root 5 cos alpha I plus 35 root 5 sine alpha j. Okay, so again, you should draw that diagram just to represent the information in the question. Okay, so we said the initial velocity vector u is 35 root 5 cos alpha I plus 35 root 5 sine alpha j. Ux is the coefficient of the I, uy is the coefficient of the j. Now here, we're looking to find the two values for alpha, given that Sx is 350 when Sy is 210. Which of these two conditions is the easier one to start with? Sx. What is the equation for Sx? Sx is ux times t. So this means 350 equals ux is 35 root 5 cos alpha times t. Now we can divide 350 by 35. What does that give? 10. Okay, so we can divide 350 by the 35, and that's going to give it 10. And then to get t in its own, 10 is going to be all over what? Root 5 cos alpha. So t is going to equal 10 all over root 5 cos alpha. So we can substitute that time into the equation for sy. Now the equation for sy is uyt minus a half g times t squared. This means that 210 is going to equal, what's uy? 35 root 5 sine alpha. What's the time t? 10 over root 5 cos alpha. And then this is minus half of g times the time is 10 over root 5 cos alpha all to the squared. Now, what happens to root 5s? They cancel. What's 10 by 35? What's sine alpha over cos alpha? Tan alpha. So all of this term simplifies to 350 tan alpha. Minus half of g is 4.9. What happens if you square 10? 100. And that's 100 over 5 cos squared alpha. Root 5 squared is 5. Cos alpha squared is cos squared alpha. So we're left with 210 equals 350 tan alpha minus 4.9 by 100 over 5 cos squared alpha. Now 5 divides into 100 to give 20. And if we multiply 4.9 by 20, what does that work out as? 98. So this means 210 is going to equal 350 tan alpha minus 98 by 1 all over cos squared alpha. You can sort of take the 98 out in front. Once again, what is 1 over cos squared alpha? 1 plus tan squared alpha. Okay, now I have just divided everything there by 7. So everything does divide by 7. 7 into 210 gives 30. 7 into 350 gives 50. And 98 divided by 7 is 14. Okay, and then we can replace 1 over cos squared alpha with 1 plus tan squared alpha. Oh, we can divide by another 2 as well. Yeah, you're right. We could have simplified that a bit more. Yeah. Okay, so I should have divided that all by actually 14. So that would have given 15 equals 25 tan alpha minus 7 on 1 over cos squared. Yeah, so I could have simplified it a bit more. Okay, it'll probably break down later on anyway. So this means 30 equals 50 tan alpha minus 14 and 1 plus tan squared alpha. Multiplying in by the minus 14, you get minus 14 tan squared alpha. And if you bring everything to the left, you get 14 tan squared alpha minus 50 tan alpha plus 44 equals 0. Yeah, at this stage, I divided by 2. And this means you get 7 tan squared alpha minus 25 tan alpha plus 22 equals 0. So this is a quadratic equation in terms of tan alphas. So this one's a little more awkward to factorize than the previous one. What is definitely the factors of 7 tan squared alpha? No choice of this. 7 tan alpha and 1 tan alpha. Okay, so they're definitely the factors of 7 tan squared alpha. What's the possible factors of 22? 22 by 1 or 11 by 2. Now, if we put 11 here and 2 at the end, we put 11 here and 2 at the end. What's 11 times tan alpha? 11 tan alpha. What's 7 tan alpha by 2? 14 tan alpha. Now, what do we need to get exactly though with the 11 and the 14 tan alpha? How are we going to get a minus 25? They need to be both minus. So that needs to be a minus 11, and that needs to be a minus 2. So this means 7 tan alpha minus 11 equals 0, or tan alpha minus 2 equals 0. So this means 7 tan alpha equals 11, or tan alpha equals 2. Now, if 7 tan alpha is 11, what would tan of alpha be? 11 over 7. And tan alpha is 2. So alpha then is going to be the inverse tan of what fraction? Alpha would be the inverse tan of 11 over 7. Or what's the other one? Inverse tan of 2. Now, if you get the inverse tan of 11 over 7, we're going to work out the answer correct to the nearest degree, but we'll also store the exact answer in our calculator in memory A. So when you store this in memory A, it overrides what you previously had stored in memory A. But okay, that's the way the memory in the calculator works. Now, if you get the inverse tan of 11 over 7, to the nearest degree, that's 58 degrees, isn't it? Yeah. And if we get inverse tan of 2, that works out as 63 degrees. Okay, but we're going to store these exact answers in the calculator's memory. Okay, next of all, calculate the time of flight in each case, correct to 2 decimal places. T equals 10 over root 5 cos alpha. So alpha is inverse tan of 11 over 7. This means T would be 10 over root 5 cos of A. Okay, so what does that time work out as the 2 decimal places? 10 root 5 cos of recall A. .33, is it? Okay, and then the other one then, if you get the inverse tan of 2, this is 10 over root 5 cos of recall B. And what's that time? 10. So that works out as exactly 10 seconds, isn't it? So you can see if you use the exact angle, it gives you the exact time. Okay. Now, there is no rounding errors in applied maths, okay? But if you're doing project maths, there is rounding errors, okay? So you would need to use that method, especially for project maths. Okay, so they're very, very common exam type questions. Okay, so make sure you're very familiar with that. Okay, so the next section then is projectiles on inclined planes. So in the exam, the first question, part A is always projectiles on horizontal planes, and part B then is always projectiles on inclined planes. Okay, there is a modification of the equations that we've been using so far. Okay, but the conditions always stay the same when you're dealing with projectiles on inclined planes, which means that at the maximum height, Vy equals 0. When the particle lands, Sy equals 0. Okay, the conditions are the same, but something does change. And what actually changes is gravity. Okay, so this is what happens when you've got projectiles on an inclined plane. So you can think of this as being maybe a hill, okay, or a road going sloped upwards. So this becomes your new y-axis. So your inclined plane becomes the y-axis. Your j-axis is then always perpendicular to the I. What does perpendicular mean? 90-degree angle. Okay. So this is your inclined plane. This is your y-axis. Okay. This is then just the horizontal. So here, the inclined plane, this is inclined at some angle beta relative to the horizontal. Okay. So this is your inclined plane. That's the horizontal, and it's inclined at some angle beta. Now, the particle is always projected from the origin. The tangent vector from the origin represents your initial velocity vector u. U is the speed, and it makes some angle alpha relative to the inclined plane. So alpha is the angle of projection relative to the inclined plane. Beta is the angle that the inclined plane makes relative to the horizontal. Now, what we need to do here is to split up gravity into I and j components. It doesn't matter if you're on a hill. If you drop an object, which direction is it going to fall? Straight down. Okay. So gravity always acts vertically downwards. Now, what we need to do is to split up this gravity into I and j components. Okay, horizontal, or sorry, not horizontal, components along the j-axis and components along the I-axis. Okay. So your I-axis is similar to the x-axis. The j-axis is similar to the y-axis. Okay. Now, if we want to split this up, now if this here is an angle beta, if I drew a line straight down here, okay, straight down so that it made a right angle down here. If that was an angle beta, what would this angle up here be then? If that went straight down. So we've used 90, and that's beta. What would this angle here be? 90 minus beta. If that's 90 minus beta, what would this angle here be? Across from it. The same. What are they called? Vertical opposite angles. Okay. Now, if that was 90 minus beta, and that's 90, what would this have to be? Beta. Okay. So when you're splitting up your gravity, we always split gravity using the angle that the inclined plane makes relative to the horizontal. Is that okay? Okay, so that's your angle beta. This is beta. Now, what we've got here then is a right angle triangle. G is the hypotenuse, and this is the angle beta. This component is the adjacent. It's beside the angle. This is G cos beta. This component is the opposite the angle. This is G sine beta. Okay. So the adjacent always uses cos, and the opposite uses sine. Because what is cos in any triangle? Cos is the ratio of which two sides? Adjacent over hypotenuse. Okay. So the cos of the angle is the adjacent over hypotenuse. So cos uses the adjacent. What's the sine of an angle? Opposite over hypotenuse. So sine uses the opposite. Okay. Okay, so this is what's going to happen. We have to formulate equations for Vx, Vy, Sx, and Sy. Okay, so this gravity change modifies the equation. Remember, we had V equals U plus AT. So the velocity in the x is going to be the initial velocity in the x plus the acceleration in the x times time. Now, the acceleration along the x is the same as the acceleration along the I. This is along the I here. Okay. And that's a minus g sine beta. Why am I putting it as a minus? It's going up the hill. Is that okay? So that would be a minus g sine beta. Okay. So the acceleration along the I is minus g sine beta. Okay. Because you're going up a hill, it's going to be a minus g sine beta. So this means ux is, now what is the initial velocity vector always? U is always what? U cos alpha I plus U sine alpha j. So ux is going to be U cos alpha. Okay, so ux is always your U cos alpha. So this means Vx is U cos alpha I minus g sine beta times t. Okay, now there's a rule you can use sort of to memorize these. If you've got a cos alpha, it's going to be followed by a sine beta. You never have a cos alpha and a cos beta. Is that okay? That's how you memorize these. If you've got a cos, it's going to be followed by a sine. Okay, similarly, we have to formulate the equation for Vy. So Vy is going to equal Uy minus Ay times t. Now you can see here, Ay is g sine beta. Now again, why is that a minus g, or sorry, a g cos beta? Why is that a minus g cos beta? It's going up, okay? So this is going up. Gravity is negative going up. Okay, and what's the initial velocity in the y? What's Uy? U sine alpha. So Vy is going to be U sine alpha minus g cos beta times t. So again, if we have a sine alpha, what's sine alpha always going to be followed by? Cos beta. Okay, so that's how you memorize these. Okay, so we're after formulating the equation for Vx and the equation for Vy. We have to do the exact same thing for Sx and Sy. Okay. So again, S equals ut plus a half at squared. S equals ut plus a half at squared. This means Sx is going to equal uxt plus a half ax times t squared. Now again, ax, this is the acceleration along the I, and that's a minus g sine beta. And what does ux always do? U cos alpha. So Sx is going to be U cos alpha t minus a half g sine beta times t squared. Once again, what followed the cos alpha? Sine beta. Okay, so that's how you memorize these. The last one then is Sy. So again, S is ut plus a half at squared. Now Sy is going to be uyt plus a half, and ay, the acceleration on the y, is going to be minus g cos beta. So ay is the same as aj. So that's going to be minus g cos beta times t squared. But again, in general, what's uy? U sine alpha. So Sy is going to be U sine alpha t minus a half g cos beta times t squared. Now, none of them equations are given in the maths and formula tables. Okay? You're expected to know them off by heart. Okay? But to be honest with you, when you do a few of these, you will know them. Okay? You will know straight away. If you start off with a U cos alpha, what's going to follow a U cos alpha? G sine beta. If you start off with a U sine alpha, what's going to follow it? G cos beta. Okay, so once you use that simple rule, it's actually, they're not too difficult to memorize these, even though they do look quite complex. Okay, so we're going to go through example 6. Okay, we will do example 5 again, but for today we're going to go through example 6. So in example 6, a particle is projected up a plane which is inclined at 30 degrees to the horizontal. The particle is projected from a point on the plane and has initial velocity 20 meters per second at 30 degrees to the plane. Okay, so it is important to make sure you get the correct angle. Alpha is the angle the particle makes with the inclined plane. Beta is the angle the inclined plane makes with the horizontal. Is that okay? So alpha is the same as what we always had it as. So the angle alpha is the angle the projectile makes with the y-axis. Okay, this angle beta, that's something new. The angle beta is the angle that the inclined plane makes with the horizontal. So we're told here a particle is projected up a plane which is inclined at 30 degrees to the horizontal. You see this angle? Is this alpha or beta? Beta. This is beta. Okay, so beta is 30 degrees. The particle is projected from a point on the plane and it's got initial velocity of 20 meters per second. So the speed is 20 at 30 degrees to the plane. So this is the angle the initial velocity vector makes with the inclined plane. Okay, that's your angle alpha. Alpha is 30, beta is 30, and the speed is 20. Okay. Now we have the same conditions as before. When the particle lands, what's the condition always? Sy equals 0. If we want to find the speed of the particle when it lands, we need to know the velocity vector when it lands. V is Vxi plus Vyj. Okay. So we will be looking at calculating that. At the maximum height, what's the condition at the maximum height always? Vy equals 0. Okay, so your conditions are exactly the same. Okay, so here the initial velocity vector u is u cos alpha I plus u sine alpha j. What's the speed u? 20. What's the angle alpha? 30. So u is going to be 20 cos 30 I plus 20 sine 30 j. You're always going to be dealing with the special angles. What are the special angles? Yeah, and you won't be doing 90 really, won't you not? Because that just goes straight up. Is that okay? So you're either going to be dealing with 30, 45, or 60. Okay. Okay, so here, if you type in 20 cos 30 into your calculator will simplify that as 10 root 3. 20 sine 30 is 10. Sine of 30 is a half. So this means the initial velocity vector u is 10 root 3i plus 10j. You cannot answer anything without knowing that initial velocity vector. Is that okay? So that's the first thing you always have to calculate. Okay, whether it be in terms of alpha or numerical values as we've got here. Okay, so you always have to calculate the initial velocity vector. All the other equations, Vx, Vy, Sx, and Sy, all of them use either Ux or Uy in them. Okay, so we need to know what Ux and Uy are. Okay, so if we want to calculate the maximum height, what do we say the condition was at the maximum height? Vy is 0. And that height is the height above the y-axis. What do we call that height? Sy. So we need to find Sy when Vy equals 0. When you solve your condition, what does it always give you? Time. So the equation for Vy is, now this is the modified one because we're dealing with an inclined plane. So Vy is Uy. Now what's Uy in general? U sine alpha. What's that going to be followed by? Minus G. What follows U sine alpha? G cos beta. Okay. So here Uy or Vy is going to be Uy minus G cos beta. So Uy is U sine alpha. Okay. So that's followed by minus G cos beta. But we know what is uy? 10. So 0 is going to equal 10 minus g times the cos of, what's the angle? Theta. 30 degrees times t. So 0 equals 10 minus g cos 30 times t. Now, what is the cos of 30? So if you put that in the calculator, the calculator gives it in third form as root 3 over 2. Okay, and we'll always leave these in third form. Is that okay? We'll never use the decimal equivalents. So this means 0 equals 10 minus cos of 30 is root 3 over 2. And when you multiply that by g, that's root 3g over 2 times t. Now, on the right-hand side, we've got a minus root 3g over 2t. If you bring that over to the left, it becomes positive. So this gives a plus root 3g over 2 times t equals 10g. Okay, sorry, I've actually multiplied by 2, just get rid of fractions. Okay, and then if I bring that over, it becomes a plus root 3 gt. And if you've got a plus root 3 gt, if you want to get t on its own, what do you do with the root 3g? Divide. So this means the time is going to be 20 over root 3g. Okay, that's the time taken for the particle to reach the maximum height. We now need to substitute that time into the equation for sy. Now, sy starts off with uyt. And what's uy in general? Uy is u. It's u sine alpha, isn't it? So what's going to follow sine alpha? Cos beta. So we're going to have sy is uyt minus a half g cos of beta times t squared. So sy is going to equal, now what's uy? That's 10. What are we putting in for the time t? 20 over root 3g minus a half g times cos of beta is the cos of 30 times the time, which is 20 over root 3g, all to be squared. Now here we've got 200 over root 3g minus g over 2. The cos of 30 is root 3 over 2. Okay, let's sort of get to know these off by heart because we'll be doing them that often. So the cos of 30 is root 3 over 2. And if you square 20, what does that give? If you square root 3g, 3g squared. Okay, so we've got g over 2 times root 3 over 2 times 400 over 3g squared. Now 2 by 2 is 4, and that goes into the 400 give 100. And the g on top, what will that cancel in the bottom? Square. So here then we're left with 100 root 3 all over 3g squared. Now we had 200 over root 3g. On the bottom here we've got root 3g. On the bottom here we just had root 3g. To get a common denominator, we're going to multiply top and bottom by root 3. Okay, that'll just give root 3 as the common denominator then. So here, this gives 200 root 3 over 3g minus 100 root 3 over 3g. And if you take these away, this simplifies to 100 root 3 all over 3g. Okay, so we're going to be using thirds here to simplify. Okay. To be honest with you, your calculator would do this for you if you didn't include the g. So if you typed in 200 over root 3 minus 100 root 3 over 3 into your calculator would give you the answer 100 root 3 over 3. And then you could just attach the g to the bottom. Is that okay? So you could do this in your calculator, leaving out the g, and then just attach a g to the answer. So we found the maximum height of the particle. Next of all, we're going to find the range. What is the condition when the particle lands? Sy equals 0. So for the range, we're looking to find Sx, and this occurs when Sy equals 0. So we need to find Sx, but this occurs when Sy equals 0. What is the equation for Sy? So Sy is Uyt. But what's Uy in general? U sine. What follows the U sine? Minus a half G. What follows the sine alpha? Cos beta. So here, Sy is going to be Uyt minus a half G cos of beta times t squared. Remember, Uy is U sine alpha. That will be followed by a G cos beta. So here we're going to put in 0 for Sy. What was Uy? Uy was n t minus a half G cos of beta is the cos of 30 times t squared. Cos of 30 is root 3 over 2. Now, if you've got root 3 over 2 by G over 2, 2 is in the bottom, we get 4, and on top we've got root 3G. Get rid of fractions, we just multiply across by 4, and 0 equals 40t minus root 3G t squared. This is a quadratic equation with no constant term. How do you factorize a quadratic with no constant term? Which is t. So we're just going to factorize out a t. And we're left with 0 equals t on 40 minus root 3gt. The trivial solution here is t equals 0. What happened when t was 0? Sy was 0. Okay, is that the time we're looking for? No, we want to know when the particle lands. So we're going to solve this other factor. 40 minus root 3 gt equals 0. This means 40 equals root 3 g times t. Now, if 40 equals root 3 gt, what would t in its own be then? 40 over root 3g. So when you solve this, we're going to divide 40 by root 3g. So this means the time of flight is 40 over root 3g. What was the time taken for the particle to reach the maximum height? Part 1, 20 over root 3g. What was the time for the range? What's the property? Double it again. Okay, so that will always be the case. So now we need to substitute that time into the equation for Sx. Okay, now Sx is going to equal Uxt minus a half G what? What are you going to replace this with? So what's Ux always? U cos alpha. That's going to change this with G sine beta times t squared. So Sx is Uxt minus a half G sine beta times t squared. So here Sx is going to equal, what is Ux? 10 root 3. The time is 40 over root 3g minus a half G can be written as G over 2 times the sine of 30 times t, which is 40 over root 3g, all to the square. Now, the sine of 30 is a half. The cos of 30 is root 3 over 2. The sine of 30 is a half. G over 2 by a half is G over 4. Okay, so this will work out as G over 4. Here, the root 3's cancel, and we're left with 400 over G. So Sx is going to be 400 over G minus G over 2 by a half by 40 squared is 1600. Root 3g to be squared is 3g squared. 2 by 2 is 4. 4 divides into 1600 to give 400. And the g cancels with the square. So we're going to be left with 400 all over 3g squared. Okay, now because this has a 3g in the bottom, we'd like a 3g on the bottom here. So we're going to multiply top and bottom by 3. So this gives 1200 over 3g minus 400 over 3g. And then Sx works out as 800 over 3g. So we found the range of the particle. Okay, so the last thing we want to find then is the speed of the particle when it lands. That means we need to try and find the velocity vector. So the magnitude of your velocity vector v is the square root of vx squared plus vy squared, and this occurs when sy equals 0. Now, we've already dealt with that condition. When we solved sy was 0, that was the time of flight. The time worked out as 40 over root 3g. Okay, so we're going to work out both vx and vy. Now, the equation for vx equals ux minus g times something by t. But what is ux in general? U cos alpha. So that's going to be u cos alpha followed by sine beta. So Vx is going to be ux minus g sine beta times t. So Vx is ux minus g sine beta times t. What did we have for ux? 10 root 3. Okay. So Vx is going to be 10 root 3 minus g times the sine of beta is the sine of 30 times t is the time of flight. And what's the time of flight? 40 over root 3g. So Vx is going to be 10 root 3 minus g times the sine of 30 by 40 over root 3g. Does anyone remember what the sine of 30 is? Half. Cos of 30 is root 3 over 2. Sine of 30 is a half. Okay, and a half of g can be written as g over 2. And 2 divides into the 40 to give 20. So we're going to get 20g over root 3. Now the g's actually cancel. Okay, so the g's cancel. So we're just going to be left with 20 over root 3. Okay, now again, this was over 1. And on the bottom here, we've got root 3. We're going to multiply top and bottom by root 3. 10 root 3 by root 3 is 30. So this gives 30 over root 3 minus 20 over root 3. And 30 over root 3 minus 20 over root 3 is 10 over root 3. Now, if you did put that into your calculator would not leave the answer like that. A calculator would never leave a square root on the bottom. Your calculator actually writes that as 10 root 3 over 3. So your calculator multiplies top and bottom by root 3. Okay, but it's fine to leave it like that. Is that okay? Just if you did use your calculator, 30 over root 3 minus 20 over root 3, your calculator would write that answer as 10 root 3 over 3, doesn't it? It just doesn't leave square roots on the bottom. Okay, so that's a value for Vx. Now we're going to get a value for Vy. Now you can see using this equation, Vy is going to equal Uy minus G what? This changes to cos of beta times t. So Vy is going to equal Uy minus G cos beta times t. So what do we put in for Uy? 10 minus G times the cos of beta is the cos of 30, and the time is 40 over root 3g. Now, what is the cos of 30? Root 3 over 2. And root 3 over 2 by g is root 3g over 2. Now, the root 3's cancel. And the g's cancel. So we're just left with 10 minus 40 over 2. Now, what is 40 over 2? 20. And what is 10 minus 20? Minus 10. What was uy? 10. Vy always works out the minus of that. You can never assume that. Is that okay? But that's a wee checking mechanism that you know you're correct. So if uy is 12, vy will work out as a minus 12. Okay? That will always happen, but you cannot assume that. You must always prove that. So we've now got a value for Vx, and we've got a value for Vy. So this means we know what the velocity vector is when the particle lands. The velocity vector is 10 over root 3I minus 10j. But we're not looking for the vector. What are we just looking for? Speed. Whose theorem do we use to get the speed? The Pythagoras theorem. So the magnitude of your velocity vector is going to be the square root of 10 over root 3 squared plus minus 10 squared. Okay. And if you put this into your calculator, this works out as the square root of 400 over 3. Okay. Now you could work out that to 2 decimal places if you like either. Is that okay? So you give that to 2 decimal places. Okay, so there is a good bit more work involved on these. Is that okay? So it does definitely take much longer, maybe 50% longer to do a question with an inclined plane rather than a horizontal plane. So for homework then, I'm just going to get you to do the next few questions. Okay, questions 16 and 17. Okay, so questions 16 and 17. So what you're only changing with these are the angles and the speeds. Okay, the method is exactly the same for all of these. But make sure you do leave your answer in sword format.